Yeah. Good evening, everyone. Am I audible?
Yes, sir.
What is the answer for the first one? Zero. Because when you take an electric dipole, a Gaussian surface is enclosing an electric dipole. So the flux depends on the total charge enclosed by the Gaussian surface. It is going to be a zero. Right. So you are given 32 capacitor, each having a capacity of 4 microfarad. How will you connect all of them to prepare a composite capacitor having a capacitance of 8 microfarad? How will you do them? So if you connect 4 of them in series, and like this you connect 8 such combinations, right? So here the capacitance will be 1. Here the capacitance will be 1. So all the 8 sets which are connected in parallel will get added up. Hence the answer will be B. Clear? Third one. A 3-volt battery with negligible internal resistance connected in a circuit as shown in the adjoining figure.
Sir, for the previous question, I got all of these.
All of these is working.
Yes, sir.
8 condensers in series. So 8 condensers in series means how much will it be? 32 by 8 will be 4, no? Oh, each is 4.
Sir.
Each is 4 microfarad means it become half. But half into 4 such groups in parallel should give you only 2, no?
Sir, I might have gone wrong somewhere. I'll check.
Let's check it again.
Okay.
Let's give a benefit of doubt. So you're saying you got all of this, no? Let's do it together. So if you take 2 condensers in series, okay? If you take 2 in series, how much is going to be the equivalent capacitance of this? It will be 2. Right? And 16 such groups.
Sir,
16,
sorry.
Yeah, tell
Sir,
me.
8 conductor in series, it is 1 by 4 into 8, right?
1 by 4 into... No. It is 1 by 8 into 4, no?
Sir, 4 microfarad, right?
4 by 8 is what is going to be the answer. Because
No,
1 by C equivalent is 1 by C1 plus 1 by C2 plus so on.
Oh, okay, sir. I got where I went wrong.
This is where you went wrong.
Yes, sir. Yes, sir.
Yeah.
Sir, can you tell how B is the answer?
Because when 4 condensers are connected in series, equivalent capacitance will become 4 by 4 because each has 4.
Yes, sir. 1.
4 divided by 4, it will become 1 microfarad. Whereas when you connect them in parallel, they get added. So this 1 will get added to itself 8 times because 8 such groups are connected in parallel.
So in parallel, it will be 8 times 4, right?
8 times 1. Because 4 are in a row, 4 are connected in series, no?
Oh, okay, sir. Got it. Yeah.
Got it? So that is why the answer is B. So mark it as important. It's a good problem. So 3-volt battery with negligible internal resistance is connected in a circuit as shown in the adjoining figure. Current I in the circuit will be answer. 3 and 3 are in series. So it becomes 6. 6 and 3 are in parallel. 6 into 3 by 6 plus 3. It will become 2. So the equivalent capacitance here is 2 ohm. I hope everybody got this. So 3-volt battery connected across 2 ohm will give you 1.5 ampere. V is equal to IR, I is equal to V by R. 3 by 2, 1.5. Right. So next is a voltmeter has a range V. What resistance should be connected in series with it to increase its range to NV? Answer, please.
Sir, N minus 1 R.
Correct. N minus 1?
R naught.
R naught. Correct. How did you get that?
Sir, we have to make the total voltage as NV, sir. So the
Okay.
total resistance should also be Rn. And
Okay.
right now, the voltmeter has a potential R0.
Okay. Potential resistance.
Sorry, resistance. Yes, sir, resistance.
Resistance R
And
naught.
then if we put if we add n-1 R0 with it, R0 cancel. So R0 n will be the
Okay. Is there any other simpler way in which you can tell me the same thing? What is the formula for series, Ra?
R1 plus R.
அது இல்ல. See, ஒரு galvanometer இருக்குடா. Okay. To that galvanometer, if you connect a resistor in series, what does it become? It becomes a voltmeter, where it can measure a potential difference of V volt. Appa V is equal to Ig into G plus R.
Yes.
Do you remember this? So V divided by Ig minus G is going to be the value of R that you need to connect in series. So can I write this as V divided by Ig minus capital G? Now, what is the value of nu V? It is N into V divided by. Shriram, are you with me?
Yes, sir.
New voltage vandu, it should measure NV da. What was the initial value it was measuring? Ig vandu V divided by R naught, correct?
Yes, sir.
Minus G vandu R naught.
Yes, sir.
Appa V and V will get cancelled. Enna varum? N R naught minus R naught. N minus 1 into R naught.
Yes, sir. Got it.
Got it. So you can use this expression itself. I hope everybody else is clear with this. Is there anyone having a doubt? Is there anyone who's not clear?
Sir, I have a doubt, sir.
Solra.
Here they're taking galvanometer resistance also or not, and normal resistance also or not, sir.
அதுதான் சொல்றேன். Whose initial resistance is R naught அப்படின்னா this இப்ப already voltmeter இருந்ததுல, but what is a voltmeter generally? Basically a voltmeter is a galvanometer connected to a resistance. So இப்ப நான் என்ன பண்ணேன்னா this galvanometer plus resistance I took it as R naught. இந்த R naught தான் you are adding a new resistance of RS. புரியுதா? So this whole combination, like how you asked, that is what I took it as galvanometer. Kaushik, purida?
Okay, sir. Yes, sir.
Purida ilya? Yes or no? Or you are saying for my sake? You still have a doubt? Get it clarified.
Sir, I can't understand how we are connecting another resistance, sir.
Illada. Basically, or voltmeter, see, that you know this concept, right? How to convert a galvanometer to an voltmeter. How will you convert a galvanometer to a voltmeter?
We connect in a series, sir.
Or a high resistance, you connect it in series. This device is what I'm calling it as voltmeter. Correct?
Yes, sir.
Read the question carefully. There is a voltmeter which already has range V. So in the voltmeter range already V. To this voltmeter, what resistance should be connected in series to increase? So in the what is the new resistance that I need to connect in series? RS dash. How much should I connect so that this whole thing becomes a new voltmeter whose range has increased by n times? Then what is the value of this RS in terms of this value? In the value that they have given it as R naught. So what I did is initial voltmeter, the smaller box. That voltmeter, I took it as a galvanometer. Question puriyada da unakku?
Sir, we are taking that old part as another voltmeter, sir.
Yes. If a small part I treated it like a galvanometer. In the galvanometer, if I connect a new resistance, then it becomes a new voltmeter. I'll ask you, how much should I connect? How much resistance should I connect in series so that this bigger voltmeter is able to measure n square V in Kekran Vechako? Then what will you do? To this circuit, You will connect another resistor in series. Upper, what you are supposed to do is in the whole voltmeter, what will you consider as? You will consider it as a galvanometer. If you want to keep increasing the range to the existing voltmeter, and the existing voltmeter, consider it as a galvanometer.
Yes, sir, I'm getting it, sir.
Getting it right. So have this concept in mind and apply. See what I did so that you will understand it better. Did you get the same answer, by the way, n-1 R naught?
Sir, I made a mistake. I got something n+1, sir. I made it wrong.
Fine. Now you got it right. Now you next time you can
Yes,
do
sir.
it correct.
Yes.
Sir,
Solra.
sir, can I tell another simpler way? Like, can you check
Yeah,
whether
tell
it's
me.
right? Sir,
Yeah, tell me.
R naught correspond to V, sir. So, like, if you write R naught equal to V,
You are using unitary method.
R naught plus X should correspond
R
to
naught plus RS should correspond to n times V.
in V.
They are
If
directly
it is-
proportional. And IG in the varum. Correct only. This is right. How do you will get the same answer. Other than the logic, actually. Because you did nothing. In the equivalent, does it make sense? IG in podren, IG in podren. Does it make sense?
Yes, sir.
It's the same thing. The proportionality, you are using unitary method. Both are right. Good that you at least you thought of this logic. So relative permittivity and permeability of a material are epsilon r and mu r respectively. Which of the following are true with respect to a diamagnetic material? Answer. This will be the answer. Because for a diamagnetic material, mu r is less than 1. So it will be
Yes, sir.
0.5. So 0.5 option A or B should be right. But remember, mu r and epsilon r will be inversely proportional. Right. So when that is going to be the case, answer is A. So this is a theoretical question. So there is a metallic ring with a cut. Metallic ring with a cut is held horizontally and a magnet is allowed to fall vertically through the ring. Then the acceleration of the magnet is. So there is a metallic ring with
Equal
a cut.
to G.
It is equal to G. So only one is right. See, had the metallic ring not been with a cut, what would have happened? Had the metallic ring been completely closed and you drop a magnet into this, what will happen to the magnets?
Less than G.
Why?
EMF will be induced. due
In
to
the law,
change it, Lenz law.
yes, because of Lenz law, there will be an opposition. Guys, I hope everyone is able to understand. So read the question carefully. This is with a cut. Since it's an open system, you cannot generate EMF. For you to generate EMF, you need a closed system. So quantity that remains unchanged in a transformer, obviously frequency. Voltage should change, high to low, low to high. Current should change, right? So if mu naught is a permeability of free space and epsilon naught is a permittivity of free space, then the speed of the light in vacuum is very, very, very simple question. 1 by mu naught into epsilon naught. It's a direct question, right? A lens of power 3.5 diopter is connected with a lens of minus 2.5 diopter. The combination will behave like a. Tell me. Effective power is how much? 1 diopter. So effective power is 1 diopter means what is going to be the effective focal length? 100 divided by 1. It will be 100 centimeter. So will it behave like a divergent lens or a convergent lens?
Convergent.
So C is the answer. So Newton gave the corpuscular theory on the basis of
Rectilinear.
Rectilinear motion.
he gave it in terms of rectilinear motion and wavefront was brought by Huygens into consideration. So the momentum of a moving particle is P. Lambda of the matter wave is very simple. De Broglie wavelength. Lambda is equal to h by P. Answer A. Charge of an alpha particle, very simple. 2 times E. Which of the following has highest neutron to proton ratio?
Uranium.
Uranium.
Which option? 13. Correct. So how much is it? 235 minus 92. That is how much is it? 143.
Yes, sir.
143 by 92.
By 92. Yes. In Young's double slit experiment, the separation of the two slits is doubled. To keep the same spacing of fringes, the distance d of the screen from the slit should be made. So beta is equal to lambda into capital D divided by small d. Beta dash kuda adedana lambda into d dash divided by d dash. So if the slit width is distance between the slits is doubled, what should happen to d dash? That should also be doubled because they are directly proportional. So capital D by D is equal to D dash divided by D by 2D. Correct? I'm just writing it for the sake of understanding. D and D will get cancelled. D dash should be 2D. A convex lens and a concave lens, each having focal length of 25 centimeter, are put in contact with the formula. The power and diopter of the combination is 0. Yes. In the middle of depletion layer of reverse PN junction diode, the answer. So in the reverse bias condition, what will happen to the size of the depletion layer? Will it increase or decrease?
Will increase.
So it will increase means what will happen to the current?
Decreases.
0. It's almost going to be 0. Because if you see in the reverse bias condition, after breakdown also, current will be in terms of few microampere. So what will happen to the electric field in that scenario? When current is almost 0, what is going to be the electric field? Will be
0.
0. Sir, why not potential is 0?
Potential will exist because charges are present. Potential will still exist. But it's the electric field that is going to be 0.
Sir, E is nothing but.
No, don't take it as E is equal to V by D and proceed. No, not like that. That is not the case. Here we are explaining the logic with the help of the charge flow. So for the charges to flow, you need a electric field. That is the reason why I told electric field is 0. A coil carrying an electric current is placed in uniform magnetic field. Okay, what will happen?
Torque is produced.
That's it. Why is EMF not generated?
Because
constant
change in magnetic field only.
Because uniform magnetic field, right? That's the reason. If sigma is the surface charge density, epsilon is the permittivity, and then the dimension sigma by E is same as
Electric field intensity.
Yes. So sigma by epsilon naught for which quantity will you get? Which device?
Parallel plate capacity.
Yes. If an electric dipole is placed in a uniform electric field with its dipole moment P parallel to the field, find the work done in dipole till its dipole moment points in the direction opposite to electric field. So how much work is done in that scenario?
Sir, is it 2 PE?
2
P into E.
Okay. So how did you calculate? Work
So
done is equal
work
to
done
change
is negative of change in potential
minus
energy.
P cos theta. Okay, minus PE cos theta Initially, what would have been the energy? Ui would have been minus PE. U2 will be plus PE. Work done is equal to delta U, that is U2 minus U1. So what will be the answer? It will be 2 times PE. Okay. The orientation of the dipole for which the torque acting on it becomes maximum. Obviously, theta should be
90.
Sir,
hmm,
sir, work done should be negative of change in potential energy.
work done is change. I wrote it as just change in potential. Why would it be negative?
Sir, according to work energy theorem, work done is change in kinetic energy, but kinetic
Okay.
energy is mostly proportional to potential energy. So it should
Okay.
be negative.
No, see, that is not the concept I took into consideration. W is equal to integral of torque d theta, right? So theta 1 to theta 2. Let's come with this scenario itself. So W will be equal to integral of P sine theta d theta. From where? Theta 1 to theta 2. What is the value of theta 1? 0 to pi. Are you in acceptance with this? So PE
Yes, sir.
will come out. Integral of minus sine theta is minus cos theta between 0 to pi. Now tell me. PE into minus cos pi is 1 minus of minus cos 0 is minus 1. So what will happen? 2 times PE. This is the work done. It's the same, no?
Yes, sir. Understood.
That's it. No, this theta is 90. Correct. Distinguish between polar and non-polar dielectrics. So polar dielectrics have a permanent dipole moment existing. Example, water, HCl, ammonia, all these are polar dielectrics.
Sir,
Tell me
is
that.
polar dielectric is same as polar molecules?
Like, can you give me an example? Which molecule are you doing?
Sir, since in the book it is given like polar molecules as water as polar molecules and CO2 as non-polar molecule.
Non-polar, because
So,
CO2, when you draw the structure and see, it is going to be having linear thing, right? C double bond O, double bond O. Dipole moment get cancelled. I think you would have learned in your chemistry, in your chemical bonding also, the name of bond moment something.
yes, sir.
Because of this reason, whereas water can go.
They get added up.
OH. Okay. Did I draw something wrong?
Sir, it's H2O, sir.
H2O.
Yeah. So it is like this, right?
Yes, sir.
So this is negative charge, this is positive charge, this is positive charge, right? Because it's an electronegative element, so the charge is going to get pulled towards it. So what is the dipole moment? This is one dipole moment, this is one dipole moment. If I take this as P1 and P2, the resultant of these two will exist here. It is a polar dielectric. Free that. Either vector, applying the parallelogram law of vectors, you have a non-zero vector existing as a resultant.
Yes,
Whereas
sir.
this will get cancelled. Negative to positive.
Yes, sir.
They
Sir,
get cancelled.
Sir, my question is like here they are asking dielectrics. So why are we writing molecules? Like if I can't we write like parallel plate capacitor as?
Dielectric is a material that is generally used between. See, why they are asking this question is, let's say tomorrow I'm giving you a task, a paper capacitor. Paper capacitor, why is it having a name as paper capacitor? Is the conductor a paper capacitor? Is the conductor a paper or a dielectric a paper?
Dielectric.
Dielectric. Adhe mari ceramic capacitor So what is the dielectric? It's a ceramic. So just to check whether you have a knowledge of what is a polar and a non-polar dielectric, they're asking you this question. So
Okay,
you
sir.
generally don't write capacitor as a dielectric. Because the concept of polarization and everything is taking within a dielectric. Correct? In a dielectric, what is there? You have small dipoles present. Those dipoles are generally in disoriented shape. You know the theory, right? So when you apply the electric field, due to torque, they get aligned in a particular direction, and then you have the polarization and everything existing. So on the concept, you need to understand what is this polar and non-polar dielectric. Just on the materials introduction, that's it. To put it very
Yes, sir.
simple.
Okay, sir.
Yeah. So to answer your question, molecules according to your book, they both are same. Polar dielectric and polar molecules are the same.
Okay, sir.
#21. There are 3 identical resistors. Each of resistance R, when connected in series with a DC source, dissipate power X. If the resistors are connected in parallel to the DC source, how much power will be dissipated? Answer. So power in series is V square divided by R. Can I take it like this? Right. Can I take it like this? So if 3 resistors are connected in series, what is going to be the value of R? I'll call it as R dash, for instance. Upper V square divided by 3R is what is X according to the statement. If the resistors are connected in parallel, then it will be V square divided by, what will be the equivalent resistance? R by 3. So what is V square
Yes.
by R? V square by R is 3X. So it is 3 times V square by R. Can I write it like this? But remember, this 3 goes to the other side. V square by R is 3X. So 3 into 3X is going to be 9X. So the power dissipated when you connect them in parallel is going to be 9 times the power that is dissipated in the series connection. I hope it is clear.
Sir, how did it become 19? Sir, 3 and 9 MDs.
From here, observe V square by R is 3X. Inge V square by R. And this 3 has gone to the numerator. 3 into V square by R is 3X. 3 into 3X is 9X.
Okay, sir. Yes.
So write Einstein's photoelectric equation, explain the terms. So what is Einstein's photoelectric equation? The energy that is supplied, H nu is equal to work function plus K max. What is threshold frequency? It is the minimum frequency below which photoelectric emission cannot take place. What about stopping potential? I think this was asked last time also. I hope I answered it. So it is a minimum negative potential that must be applied on the anode to completely stop the electron from reaching it. Right. State Bohr's postulate of. Tell me. Yeah.
Can we say to make the kinetic energy 0?
That is also same.
Okay.
When you say kinetic energy is 0, you're indirectly saying the particle is stopped. Both are same.
Okay.
Yeah.
Sir,
the
acceptor plate is anode.
Yes. The collector plate.
Yes, sir. So the negative potential is given to
anode. Anode on the electrochemistry, I think it is different, correct? Is it confusing you? I'm just asking you a question. Electrochemistry, the difference or anode cathode. I'm asking you by not knowing it. Nitish?
Sir, it's same, sir.
Same then, huh? Okay.
Yes.
Because sometimes in chemistry they use a reverse terminology. So you give it to anode. That is a positive terminal as well as negative. Anode is basically collector plate.
Yes,
When you draw the graph itself, you'll say anode potential, you write it. You'll not write it as potential difference. Anode potential, this side will be positive, this side will be negative. Here is where you'll have that V naught.
Okay, sir.
State Bohr's postulate of hydrogen atom, which successfully explains the emission lines in the spectrum of hydrogen atom. Answer. Which postulate of Bohr is used to explain the spectrum formation? It is a transition that is taking place by the electron from the higher energy level to the lower energy level. So what is it? H nu is equal to E2 minus E1. What is this condition called as Bohr's? It's called Bohr's energy condition or frequency condition. What is it called? Bohr's frequency condition. What is the other postulate?
Quantization.
What is quantization condition? Angular momentum is
The angular momentum is basically integral of h by 2 pi.
Integral multiple of h by 2 pi. Wherever you see integral multiple, that is a concept of quantization. I hope everybody did this problem. Calculate the binding energy. First, you need to calculate the mass defect. So what is the mass defect? Theoretical mass minus practical mass. So how much is it going to be? 83 into mass of 83 protons are there. 83 into 1.007825 plus 209 minus 83. How much is it? 126. 126 into 1.008665. Right. This is going to be the theoretical mass minus what is going to be the mass that is measured on the spectrometer, mass spectrometer. It is 208.980388 AMU. So when you subtract these two, you will get the mass defect as, I'll tell you the value. 1 minute, let me check. It is given as 1.760877 AMU. But 1 AMU is equivalent to how much mass? How much energy?
931.
Correct. 1.760877 into 931.5 mega electron volt. They ask the binding energy per nucleon. Okay, binding energy. This is binding energy. So binding energy per nucleon 1.760877 into 931.5, the whole divided by what is going to be the mass number? 209. So that will give you the answer as 7.85 mega electron volt per neutron. Actually, you can write it as by A also, mass number. Sorry, not neutron, nucleon. Right. What are microwaves, sir? So basically, microwaves are radio waves of smaller wavelength. Right? They are comparatively of smaller wavelength. And how are they produced? They are produced by oscillating electric field. Sorry. Circuits. Right. And what is going to be one of the use? Obviously, use it in microwave ovens. And it is also used in communication purpose. 26. With the help of a ray diagram, show how a concave mirror is used to obtain an erect and magnified image of an object. When can a concave mirror produce a virtual and erect image?
Object between pole and focus.
Yes. So when you place it here, this is Okay. Now using the above ray diagram, obtain the mirror formula. Could you obtain it? Could you derive the values? So if I take this to be A dash, B dash, and if I take this to be AB, am I right? So the curvature, generally you take it to be small. Okay, keeping that aside, tell me what are the triangles you're able to see? If this is going to be R, this is going to be U, and this is going to be V. So how do we derive it? Tell me. What are the two similar kinds of triangles that you're able to see?
Sir,
ABP, A dash, B dash, B.
Sorry, one person at a time. BAP. Yeah, BAP.
B dash, A dash, and P dash, sir.
B dash, A dash.
P dash, P, sorry, sir.
Mean to say this angle and this angle are same.
Yes, sir.
How?
Sir, if you take, sir, like if you draw a perpendicular line on the mirror, you will get the same height as of the object. So it will be, the other angle will be 90 minus theta, 90 minus I.
But you're
And then-
considering 1 minute. You're considering this to be a straight line.
Yes, sir.
Sir,
But how can you say that is a straight line? Because
Sir.
that depends on the size of the object. No?
Sir, otherwise you could do it this way also, sir. Since it is like falling on the principal axis, the incident ray will be equal to the incident angle will be equal to the reflected angle, right?
So this will be
Hi.
theta, this will be theta.
Yes, sir.
So
And
it's
then
vertically opposite.
yeah, vertically opposite angle, sir.
Okay, that is fine. Yeah, Nitish, you were about to say something.
yes, sir.
So
That's
BA,
logic only. Yes, sir.
so triangle, yeah, B dash, A dash, B. So according to the AA criteria, they both are similar. So I'll take B dash A dash divided by BA is equal to A dash B divided by AP. Okay, so this will be V divided by minus UR. Equation number 1. Similarly, what are the other triangles we can think of? B dash A dash C is similar to triangle BAC, correct? Because C is the common angle. Upper B dash A dash divided by BA will be equal to A dash C divided by AC. What is A dash C? A dash C is, how did you take A dash C as?
Sir, minus F plus V, sir.
A dash C, ma. C is radius of curvature.
2F plus 1.
2F, sir. Sorry.
So you took V minus 2F divided by what is AC?
Sir, A dash C is V plus 2F.
Sign convention.
Sir, but while deriving, we don't apply sign convention.
We have to. I told you, no, while deriving also you have to apply it while solving problems also. This is minus V by U. That is why I wrote minus U here. Did you get the same answer without the sign convention? Let me check. So what is AC? AC is negative of R minus U. As of now, I leave it as R itself. Tell me. Minus V by U is equal to V minus R divided by negative of R minus U. Minus and minus will get cancelled. VR minus VU is equal to VU minus UR. Bring this side, take this to the other side. VR plus UR is equal to 2UV. Divide it with UV on both the sides, which implies, sorry, UVR on both the sides. So you will get 1 by V plus 1 by U. Sorry, 1 by U plus 1 by V is equal to 2 by R. This is what is mirror formula, no? 1 by v plus 1 by u is equal to 1 by f. This is where you need to be careful. You need to apply sign convention while deriving as well as while solving problems. Define the term electric field intensity. Electric field intensity is the amount of force acting per unit positive charge kept at a certain distance. What is going to be the SI unit of it? It is going to be Newton per Coulomb or volt per meter. Generally, we write it as Newton per Coulomb only. Derive the expression for electric field intensity due to a dipole on the axis of it. It's a theoretical question. I'm leaving this to you. So what will be the value? It will be Kp divided 2 Kp divided by R cube. And it will be in the direction of dipole moment P cap. 27.
Sir,
Tell me that.
Kp cos theta by R square is on any point, right?
Any point other than the axial or equatorial, but that's not a part of your syllabus. Kp cos theta by R cube and the Kp cos theta concept will come in the potential. That is there. You calculate the potential at any point other than the axial and equatorial. Whereas for electric field, you will calculate only on axial and equatorial. Yeah.
Sir, electric field also, it's root over 1 plus 3 cos theta.
Yeah, that's not a part of CBSE is what I'm saying. It comes only for competitive exam. Because you will resolve that and then solve it. See, you know the values along axial point. You know the value along the equatorial point. So you will take the axial and equatorial, resolve it along a particular direction and then solve it. That cos theta also you need to understand with respect to which you took. Did you take it with respect to
Center
equatorial?
of dipole.
Yeah.
Sir?
So with okay, anyways, don't worry, that is not a part of CBSE. That will not be asked.
Sir? Sir, 21st question that 3 identical resistor you told, right?
Younger 21.
Sir, here series now we usually consider I square R only, right?
Okay,
Since
I square what is going to be the value of I? Sorry, I is equal to V divided by R equivalent only, no? R equivalent 3R then.
3, okay.
Then you will calculate only across the power across each value. Generally, we don't do it like that. Power would actual formula on the V square by R term. Means when you're solving a problem, right? This is what confuses. Since you asked, I'm telling you, you can either use VI or V square by R or I square R. I would suggest use this. Always find the equivalent resistance and use the voltage into consideration. That will give you an easier answer.
Okay, sir.
Others, you have to be careful. You will calculate current across either power calculate. You need to calculate equivalent value. All that is headache.
Yes, sir. This is simpler. Yeah.
Given figure shows two current carrying wires iron to find the magnitude and directions of the magnetic field at point P, Q, and R. Answer. So magnetic at point P, okay. Magnetic field due to 1 at point P is how much? Mu naught by 4 pi. So look at the formula mu naught I divided by 2 pi R, no?
2 mu naught I by 4 pi R.
The mu naught I by 2 pi R, no? Okay, you wanted to take mu naught by 4 pi as 10 power minus 7.
Yes,
so this will become 2 into 10 power minus 7 into current is 20 divided by what is the value of R? It is going to be 10 into 10 power minus 2. So what is the direction of magnetic field to the first conductor at point P? Is it into the plane or out of the plane?
Out of the.
Correct. It is going to be out of the plane. What about B2? Mu naught I divided by 2 pi into what is the value of R? 10 plus 10 plus 10 is going to be 30 into 10 power minus 2. 2 into 10 power minus 7 into 20 divided by 30 into 10 power minus 2. It is going to be into the plane. Sorry. It is going to be into the plane. So what is going to be the net magnetic field? It is going to be B1 vector plus B2 vector. Add them and that will give you the required respective answer. Okay. I hope you guys understood the logic. I'll just tell you the answer. I'll tell you. 2 into 10 power minus 5.
Sir, you took us 20, sir. It should be 30. On B2.
Which one, sir? Oh, this is 30.
B2. Yes.
30. This and this will get cancelled. This and this will get cancelled 2 times. So it is going to be 4 into 10 power minus 5. This will be 2 into 10 power minus 5. Answer is 2 into 10 power minus 5 in the outward direction. Right.
Yes, sir.
What about Q? Q, who's going to dominate? 30 ampere will dominate. So,
Sir, Q both will come in one direction.
Oh, they both are in same direction. Okay. So they're into the plane. 2 into 10 power minus 7 into I'll do one thing. 2 into 10 power minus 7 divided by the distance is also same. 10 into 10 power minus 2. So into 50 will come. That will be into the plane. This will go 5 times and this will go 10 times. So answer will be 10 into 10 power minus 5 Tesla, or it is going to be 10 power minus 4 Tesla, which is into the plane. All right. So let me check the answer alone. 1 minute. Question number 28. 28. 10 power minus 4 Tesla pointing normally inward. Correct. What about R? For R, due to 1, it will be into the plane, and due to 2, it will be out of the plane. That's it. So 2 into 10 power minus 7 divided by 10 power minus 2 is common. So it will be 20 divided by 30. 20 divided by 30. This is minus 20 by 30 because into the plane. Plus 30 divided by 10. That is out of the plane. So 2 into 10 power minus 5 into 3 minus 2 by 3. How much is answer? 3 minus 2 by 3, 7 by 3. So 14 into 10 power minus 5 divided by 3, which will be out of the plane. Okay. Show that in a parallel plate capacitor, the medium between the plates of a capacitor is filled with an insulating substance of dielectric constant. Capacitance increases. Can you guys show it? And by what factor does it increase?
Do we have to derive the thing for this question?
So C is equal to Q by V is what you need to do whenever they ask about. So C is equal to Q by V. Q divided by V is written as E into D. So Q divided by charge is the same. When you place a dielectric, what is going to be the electric field? Electric field will become sigma divided by K times epsilon naught. Because electric field will decrease by a factor of kappa into D. So Q epsilon naught or Q epsilon naught by sigma will become epsilon naught A divided by D, the whole thing multiplied with K. This K will go, sigma I wrote it as Q by A, so Q divided by Q by A, this and this will get cancelled, go to the numerator, that is why I replace with A. So epsilon naught A by D is C naught. So the capacitance increases by a factor of kappa times. So who's the reason for the increase in the value? It is because of the decrease in the value of electric field. Okay. Deduce the expression for the energy stored in the capacitor C with charge Q. So how do you derive it? So you will say dW is equal to
VDQ.
VDQ. In the place of V, you will write it as Q by C, integrate on both the sides, you will get Q square divided by 2C. If you have doubt, refer to the videos. Define mutual inductance between a pair of coils. Derive an expression for the mutual inductance of two long coaxial solenoids of the same length wound one over the other. So how do you define mutual inductance between two coils? I told you last time also, I think the same question came.
Sir, that is self-inductance.
Okay, what is mutual inductance? But I remember mutual inductance last time. Ilya, M1 to M21. Did I give you? I don't remember. Check the paper once. So mutual inductance, you can define it later. If there is an EMF getting induced in the secondary coil due to the change of current in the first coil, you call it as mutual inductance. Similarly, the vice versa. So that is mutual induction. I'm sorry. That is a phenomenon. But here they ask mutual inductance. So how do you define M1 or M12? How do you define it as?
Sir, the phenomena, what is that, sir? Mutual?
That is, see, phenomena. When they ask you a question, be very careful. If they ask mutual induction, then write the phenomenon. If they ask mutual inductance, then speak about the constant M.
Yes, sir.
Purida, so M12 is equal to what? N151 divided by I2.
I2.
So N151 will be equal to how much? M12 into I2. So if I differentiate on both the sides, then I go EMF. EMF is equal to minus M12 into di2 by dt. Am I right? So if I make di2 by dt is equal to 1, it becomes unity. Then EMF will be equal to M12. Am I right? Now give a definition to it. So mutual inductance is numerically equal to the EMF when the rate of change of current is unity. Purida, I repeat it. Mutual inductance is numerically equal to the electric field if the rate of change of current is unity.
Sir, the rate of change of current in the adjacent coil, right?
No, adjacent. It can be generally
I2.
Generally, generally the coil which carries the current is called as primary coil. Adjacent is the coil generally whichever is carrying the current is said to be the primary coil.
Okay.
And EMF is always induced in the secondary coil. So Anil, if I have to be more specific, I can put the statement like this also. Mutual inductance is numerically equal to EMF when the rate of change of current in the primary coil is unity. When the change of current in the rate of change of current in the primary coil is unity.
Okay.
Yeah. In an LCR circuit, in a series LCR circuit is connected to an AC source having voltage V is equal to Vm sin omega t. Derive the expression for the instantaneous current and the phase relationship of the applied voltage. Obtain the condition for resonance to occur. Define power factor. State the condition under which it is maximum and minimum. So what is the value of I, guys? But what are they asking? Derive the expression for the instantaneous current. So I is equal to how much? V divided by Z. So it is Vm sin omega t divided by Z is how much? Root of R square plus XL minus XC the whole square. Right. So this is going to be the value of instantaneous current. Now, how will you define the phase relation to the applied voltage? Okay. Instantaneous current and its phase relation to, okay, this is what we got. That's fine. Obtain the condition for resonance to occur. So when will resonance occur? Resonance will occur when the current is maximum. When current is maximum, Z is minimum. When Z is minimum, XL will be equal to XC, which implies omega R is equal to 1 divided by root LC. Okay. State the condition under which it is maximum and minimum. So when will the power factor, what is power factor, guys? Cos phi is equal to R divided by Z. R is the resistance and Z is going to be the impedance. So when will this be maximum? Maximum obviously when theta is 0, and minimum when the value of theta is equal to 90. I hope you understood. Maximum is 0, minimum is 90. When a plane wavefront of light of wavelength lambda is incident on a narrow slit, an intensity distribution pattern of the form is shown and is observed on a screen, suitably kept behind the slit. Name the phenomenon observed. What is this, guys?
Diffraction.
Correct. Obtain the condition for the formation of central maxima and central. This referred to the theory video. Why is there a significant fall in intensity of the secondary maxima compared to the central maxima, whereas in double slit experiment all the bright fringes are of same intensity? Answer. Answer. Did you understand the question? When you talk about the intensity pattern observed in Young's double slit experiment, they say almost all the fringes have the same intensity. It is an important question. Whereas when you observe the same thing with respect to a diffraction, the intensity seems to be decreasing compared to the central maxima. What is the reason for it? It lies in the other name for diffraction. I would have told this. Diffraction is also called as, see, this is not a commonly used term, but this is to be understood. It's called as a single slit interference. What is the meaning of it? Means from a single slit, there is only one source of light. Tell me one thing. What is the reason for the formation of bright fringes in the case of diffraction? What is the logic we are giving for the reason? When you break a single slit into odd number of slits, right? When you break it into odd number of slits, there are going to be 3 rays which will come out in such a way. There will be 2 rays which will undergo destructive interference. Then why is the bright fringe formed at the point on the screen? It is because of the extra light that is left out. So if I have one single source, out of the single source, only a fraction of that is going and falling on the screen. And because of that fraction going and falling on the screen, you're able to see that there is a decrease in the intensity that is happening. Guys, are you able to understand what I'm saying? If I take this to be the first bright spot rather than the central maxima, there will be 3 rays. No. Out of the 3 rays, 2 rays will undergo destructive interference. See, first of all, this 3 rays itself is coming from one source. In that one source itself, if a part of it is undergoing destructive and only a fraction of it is going to go and fall on the screen, what will happen to the intensity? Obviously, they get decreased. Puriyadada? Are you able to understand?
Yes, sir.
Very good. So when the width of the slit is made double to the original width, how is the size of the central band affected? Answer.
Sir, I have a doubt, sir. Sir, generally in diffraction, like how can we say like 3 rays? Sir? There can be like infinite rays, no, sir. Like each point can act as a source, no, sir.
Illa, we break it into multiple slits. No, that is the explanation we give. How many slits are there actually? How many slits are there? It is only
one, sir.
One slit. Go through the explanation that I would have given for the first maxima, second maxima. Okay, as one I would have told first secondary maxima. See, the central maxima is called as the brightest spot. Other than central maxima, all other maxima are given a prefix called as secondary. You call it as first secondary maxima, second secondary maxima. So how is the first secondary maxima formed? How is the first secondary maxima formed? That's the reason, Kaushik.
Sir, it is formed with a low intensity.
Illa, eppadi varudhu? What is the justification you are giving that this spot is bright because of this reason? Simple logic. If a spot has to be bright, anga light vidanum, correct? If light goes and falls in a particular spot, you call it as a bright spot. If light is not falling in that area, you call it as a dark spot. The first point is clear. That is a very basic thing of brightness and darkness. That is a basic definition. Second question, if I take two rays, okay, this is a theoretical explanation I'm giving. I'm not saying this is the exact thing that is happening. So I'm taking one slit. If I break that slit into two parts, such that this part is A by 2 and this part is A by 2, if these two rays are going and falling at a particular point in such a way that these two rays nullify each other in the sense they undergo destructive interference, then what will this spot be? It will be a dark spot. Correct? So in the dark spot, you will have a bright spot here. So the explanation, theoretical explanation I'm giving is I'm breaking it into three slits. There's one slit of width A. I'm breaking it into A by 3, A by 3, and A by 3. Out of these three A by 3s, there are two consecutive rays which are going and falling on the screen in such a way that they both cancel out each other. Up on the spot. Kaushik, I need an answer. If these two subsequent rays go and fall on the screen in such a way that they cancel out each other, they undergo destructive interference. What is the outcome of the subsequent rays?
It behaves as a dark fringe.
They should become dark, but on the spot dark because dark we already saw. So third ray, so we actually slit into three parts. Now the third ray, that third ray is going and falling on the dark spot so formed due to the subsequent rays in such a way that the brightness at this point is formed due to this last ray that is coming from the third slit. One source itself is broken into three rays. Out of those three rays, only 1/3 of the ray is actually contributing to the bright spot. A fraction of it is only contributing, correct?
Yes, sir.
So on the fraction, the intensity is getting decreased. Whereas in Young's double slit experiment, there will be two rays from two different slits. They are two real slits. But here what is happening? It is only one slit. We are giving an explanation saying that it is broken. If it is broken into three slits, then this would have happened. So
bright fringe தூரம் எடுத்துட்டு போக A by 3 A by 5 ஆகி கொஞ்சம் சிங்கிள் சோர்ஸ் ஸ்ப்ளிட் ஆயிட்டே வந்திருக்கும் சார்.
Exactly, that is what I'm trying to say. இதுவே பார்த்தனா ஒரு ஸ்லிட் தான இருக்கு. இது first secondary maximum. So second secondary maximum ஒன்னு இருக்கும்ல. To give an explanation of how that second secondary maximum is formed, one ray is there. So how many portions are you supposed to divide the slit into to give an explanation for the second secondary maximum? How many portions are you supposed to split it into? You have to split it into 5 parts. Kaushik, are you with me?
Yes.
And the 5 spots la enna பண்ணுவோம்னா, so 5 la 4 rays will be in such a way that the first 2 rays will undergo destructive. அப்ப அந்த இடத்துல என்ன ஆகும்? Dark spot. The third and the fourth ray will go and fall on the screen undergoing destructive interference. அங்க என்ன ஆகும்? Dark spot. So in the fifth ray இருக்கு பாத்தியா, that does not have any counterpart to get nullified. So the fifth ray will go and fall on the so-called dark spot to give you a little bit of brightness. So how much fraction of the original ray has actually contributed to this? If our original ray intensity aina, how much has been contributed for the second dark spot?
1/5.
It is 1/5
I by
of the total, 1/5 of the total portion is contributed. So 1 by odd number of the portion is actually contributing to each bright spot as you keep moving away from the central maximum. That is why the intensity decreases. That is the reason why the graph is like this for a diffraction pattern. புரியுதா? Next. So if the solra.
Sir, can you write the expression for secondary maxima?
Secondary maxima என்ன ஆகும்? A by 3 sin theta will be equal to lambda by 2. A by 3 sin theta will be equal to lambda by 2. அப்ப A எவ்வளோ? Or A sin theta எவ்வளோ? A sin theta will be 3 lambda by 2. So the condition for secondary maxima is A sin theta should be equal to 2n plus 1 into lambda by 2. This is what is supposed to happen.
Okay, sir.
It will exactly look the opposite of what happens in constructive and destructive interference.
Yes, sir. But yes, sir. But there we took 2n minus 1, sir.
There we took it as 2n minus. I would have taken
Distance.
it as y plus 1 and solirukkan. You can even take 2n plus 1 also, but you should take the suffix as n minus 1. Adu na solirukkan. Observe that point. I would have told that point very clearly. Recollect and see. When the width of the slit is made double the original length, how is the size of the central band affected? If the width of the slit is increased, size of the central band will decrease.
You told like wavelength and slit, width of the slit should be comparable for diffraction to take place.
Exactly. That is the reason. That is the reason it will get halved.
Sir, halved. Okay, but I wrote like diffraction will drop and then finally become 0.
That is there, but here only they doubled. No, it is not made very large. Had they used the word very large, then the diffraction pattern would have died. Then all the rays would have got combined and it appeared like a single fringe. So in it will get halved. So that's a good question and a very important question. I want everybody to make a note of it. So using Gauss theorem to find the electric field due to a uniformly charged large plane thin sheet with a surface charge density sigma. An infinitely large thin plane sheet has a uniform surface charge density sigma. Obtain the expression for the amount of work done bringing a charge q from infinity to. So first one I'm leaving it to you. It is going to be sigma divided by epsilon naught. Using Gauss theorem. That is due to one side. If you add both, it is going to be
sigma by 2 epsilon.
By large plane. That is due to one side. You're writing
both sides.
Due to one side, it is sigma by 2 epsilon naught. In the side, it is sigma by 2 epsilon naught. And if at all you take the other side, it will be sigma by 2 epsilon naught. That is why they get added in the case of parallel capacitors.
No, sir, they've just asked one plane sheet, right? They have not asked parallel.
That is one means, so you take it as sigma by epsilon naught. Sorry, 2 epsilon naught. That's right. So I'm not saying due to one sheet, it is due to one side.
One side, yeah, yes.
It is due to one side. In the side, charge the sigma by 2 epsilon naught. An infinitely large thin plane sheet has uniform surface charge density sigma. Obtain the amount of work done in bringing a point charge q from infinity to the point at a distance r in front of the charged plane sheet. Answer. So how do you calculate the work done? Work done is equal to force into displacement. So dW is equal to F into dr. So there is a particle at infinity and the particle is brought to a distance r from the plane sheet. So when the particle is brought from infinity to R, let's say at some instant, what is going to be the value of force? Force will be E into Q. So what is the electric field due to one side of the sheet? It is sigma by 2 epsilon naught into what is the value of Q? Q is Q only. That's what they have given. Q into dr. So this is dw. Integrate on both the sides. When you integrate on both the sides, w will be equal to sigma into q divided by 2 epsilon naught into r. That's the answer.
Same thing we can also do by VDQ, right?
VDQ. VDQ பண்ணக்கூடாது because you're not moving a small charge. You're moving a fixed charge to a small distance.
Point charge.
அதான்டா point charge தான்டா. Why I use dr is because infinity ல இருந்து r வரும்போது you take small distances dr. The integral of all these dr's is what is this total work done. So you should not take dq. dq meaning enna, you're trying to bring small charges from infinity. You're bringing dq from here like that. அப்படி வராது. So did you get the same answer using
Yes.
VDQ? VDQ means இல்ல ஏன் அதை யூஸ் பண்ணக்கூடாதுன்னு சொல்றேன்னா, because see, in this case force is a constant, Q is constant, E is a constant. Fortunately, E is a constant in this case. புரியுதா நான் சொல்றது? So force will be a function of displacement. So work done க்கு basic அதுதான்.
Sir,
okay, but you வந்து VDQ எடுத்தனா எனக்கு ஒன்னு சொல்லு. VDQ ல what did you take that V as?
ER.
You took V is equal to ER. See, you will take V is equal to ER only when the distances are smaller. Why we took that V is equal to ER in the case of a capacitor is because capacitor is ரொம்ப சின்ன device. It is a very small device. Only for that kind of a scenario you can take electric field as a multiple of the distance. Let me think of your logic. V is equal to, you took it as ER. dqi you integrated from 0 to q. See, do you get the right answer? I'm just thinking of the logic. V into dq. V into dq is a change in potential energy. Seems to be right only. Seems right only.
Sir,
you can do it in this case because the electric field is uniform.
Yes, sir. This point you told before also, sir.
Yeah. Because in the capacitor also we did the same thing because the electric field is uniform. That's why it works. But I would suggest be careful, go with this. If for example, இதே இடத்துல வந்து had they given a linear charge னு வெச்சுக்கோங்க, அப்ப என்ன இருக்கும்னா you would have not used sigma by 2 epsilon naught. You would have used lambda by 2 epsilon 2 pi epsilon naught r. அப்படி யூஸ் பண்ணும்போது then you will have dr. அப்ப integrate பண்ணும்போது you will get ln r. புரியுதா?
Yes, sir.
அப்ப dq எடுத்தனா இங்க என்ன பண்ணுவ? You will saying here you are taking dq, but how will you represent dq as a function of r? You will get stuck. Mathematical form பண்ற கஷ்டம். நான் சொல்ற புரியுதா இல்லையான்னு தெரியல. I'm not able to understand if you are able to catch it.
Yes,
Are you able to get my logic? What I'm saying is always when you're asked to calculate work done, go with the standard formula. Don't go with the formula which is derived for the condition of electrostatics. VDQ ன்றது it is only applicable for electrostatics. But F into dr is universally applicable wherever you do work. Mechanical work or electrostatic work or magnetic work or everywhere F into dr is applicable. So abdi po. Always express force as a function of r and then proceed. It will be easy. Either நீ வந்து because of this constant electric field you escaped. இல்லனா வந்து மாட்டிருப்ப. ஏன் மாட்டிருப்பேன்னு சொல்றேன் பாரு. You would have taken lambda by 2 pi epsilon naught r. This is electric field into you took this distance as r. இங்க நீ dq ன்னு போட்டிருப்பியா? கரெக்ட்டா? So இந்த r cancel பண்ணிருப்ப. First of all you should not do that. Upon the end of one where you will multiply this and see what are you missing. You are actually missing a big function, log function. Your answer will go wrong. So I'm just giving an explanation so that you'll understand it better.
Okay.
Nitish Purita, next time அது பண்ணாத. VDQ use பண்ணாத.
Okay.
So moving coil galvanometer is a sensitive instrument which is used to measure a deflection. So what will you say? Answer: a moving coil galvanometer is an instrument which is used to measure EMF. It is not a measuring device. Measure potential difference. No. Measure resistance. No. It's a reflection instrument which gives
Option D,
reflection.
sir.
D is right. To make the field radial in moving coil galvanometer, what happens? You have a
Horseshoe
concave shape. You give. Oh, sorry. Illada, you cut it in the form of cylinder, no?
Sir,
Cylindrical. Horseshoe கிடைக்காதுடா. Horseshoe இப்படி இருக்கும், parabolic pathல இருக்கும். Whereas when you cut it in the cylindrical part, you will have the radial magnetic field existing because they are pointed towards the center. Horseshoe on the parabolic, they'll be focused towards the focus. இருக்காது அப்படி. Centerல மட்டும்தான் you will have this kind of thing exist. The answer is poles are cylindrically cut.
Okay.
The reflection in moving coil galvanometer is third one. So how do you write the deflection in the first place? Torque is equal to I theta, I phi எழுதலாம். NBA, so number of turns, NBA is what is going to be the magnetic dipole moment into I. So this is going to be equal to, sorry, NIA into B is equal to I into phi. அப்ப phi வந்து என்னவா இருக்கும்? NBA, sorry, K into phi. Yeah, K into phi, sorry, by K. இப்ப சொல்லுங்கடா. Directly proportional to torsional constant கிடையாது. Directly proportional to the number of turns, yes. Inversely proportional to the area of the coil, wrong. Inversely proportional to current, wrong. So B is right. In a moving coil galvanometer having a coil of n turns of area n carrying current I is placed in radial field of strength B, then the torque acting on the coil is torque is here.
Option D.
Option D is the right answer. What about this? There is also a simple question. Refractive index of a medium depends upon does it depend on the nature of the medium? Yes, it does. What about the wavelength of the light used? Yes, it does. That's what happens for a prism. What about temperature? Yes, it does. As you keep changing the temperature, refractive index of the medium will change. That is how you observe mirage and all other things. Guys, are you able to understand what I'm saying? See, for example, you have seen, right, these agarbattis and all will be there. No? If you pass smoke like this, if you switch on 4 or 5 agarbattis, you try to look through it. What will happen? How will you observe the object on the other side? You feel it will be shaking, right? Are you able to understand? So this is not dependent on temperature. Because by you doing it, you're actually changing the temperature of the surrounding. So all these things come into picture. A ray of light of frequency 5 into 10 power 14 hertz is passed through a liquid. The wavelength of the liquid measured inside the wavelength of the light measured inside the liquid is found to be 450 into 10 power minus 7. Refractive index formula. Mu is equal to C divided by F. C divided by speed of the light in vacuum by the speed of the light in medium. C divided by, what is the speed of the light in medium? It is F into lambda.
U lambda.
3 into 10 power 8 divided by F 450 into 10 power minus 9 into lambda 5 into 10 power 14. Solve panna, what is the answer you're getting? 1.33 is what you're supposed to get. A ray of light is incident at an angle 60 degrees on one of the face of the rectangular glass slab of refractive index 1.5. The angle of refraction is. So this is 60 degrees, this is 1.5. This angle is going to be R. 1.5 into sine R is equal to sine 60. Sine 60 or root 3 by 2. So sine R is equal to root 3 divided by 3. Root 3 is 1.73 divided by 3. Eவ்வளவு வருதுடா? 0.6 something. Is there an option? No, 0.5 something.
It's 0.58, sir.
0.58. Is the answer? Okay. Fourth one another. A point object is placed at the center of a glass sphere of radius 6 cm and refractive index 1.5. The distance of the virtual image from the surface of the sphere is. Answer. A point object is placed at the center of the sphere and this is 6 cm. Refractive index is 1.5. Outside medium's refractive index is 1. So mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by r. So mu2 over 1 divided by v is what we need to find. Minus mu1 over 1.5 divided by u is 6 is equal to mu2 minus mu1 is minus 0.5 divided by r is 6. So 1 by v is equal to 1.5 minus 0.5 divided by 6. Over the 1 by 6. So v is equal to 6 centimeter. Correct?
Yes, sir.
6 is the answer. That's it. So I hope this paper was okay. You guys could solve it. See, you can expect some questions of this standard. See, mostly focus more on derivations part. Problems you will be able to do it. Focus more on derivations part and ensure you have a proper notes for them. Okay. Is it clear? Any other questions, guys?
Yes.
Any other questions?
Sir,
Tell me.
quantity that remains unchanged in a transformer. If power was an option, can we choose power, sir?
Yeah, power also. See, they'll not give you like that. Power frequency abhi kudutha. Instead of frequency, had they given it as power, that's okay. But the power and frequency in kudutha, it doesn't make sense. Two options are right.
Okay, sir.
Okay. That's it. So if there are no more doubts, we'll wind up. Shall we?
Sir,
Okay.
sir, B is equal to nu naught I by 2 pi A. It is only for infinite wire, no, sir. For the
It is of
28th
infinite wire.
question, it was not mentioned infinite, sir. Can we take
Long
that
and solid. Long and solid.
No, sir. Adu kudukla, sir.
You can actually by default take it unless the length is not given. That is
Okay,
as
sir.
per your textbook. That's one the competitive exam, you need to be very careful. You know that mu naught I by 4 pi into sin alpha plus sin beta is not a textbook formula. So with respect to your CBSE and it is only long conductors that are there.
Okay, sir.
And the question is
28, sir.
28. Sure. You can take it because current per there are no endpoints also. No? So you can take it
yes,
to be, you can take it to be long.
Sir, and the power question itself, sir. 3 resistors.
ஆமா 20
அதுல total power is only X, no, sir?
total power when you connect it in series.
Then how did it become 3x, sir? நீங்க 3x போட்டுருங்க. Yes.
See. When you connect it in series, equivalent resistance 3R.
Yes.
Equal power voltage எவ்வளவு கனெக்ட் பண்ணிருக்கு? V. கரெக்ட்டா?
Yes, yes, sir.
இப்போ இதோட பவர் என்னது? V square divided by R equivalent, that is 3R. This is what is given as X. அதான கொடுத்திருக்காங்க.
Yes, sir.
Then V square by R எவ்வளோ? 3X. Let this be equation number 1.
Oh, okay, got it, sir, got it. Yes.
Got it?
Yes, sir.
Yeah.
Sir, அப்புறம் அந்த microwaves textbookல it is said produced by magnetron valve. அது கொடுத்தது, sir. Can we write that?
Go with that. Yeah, go with that. Go with
Yes,
the textbook part. Go with textbook part. Whatever is given, go with it.
Yes. Thank you, sir.
Yeah, okay.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah. Samir, are you there? Samir? Samir?